All right, guys, are you in? Are you live? How many are we on this live chat? Are we live, guys? Today I decided to be on time, so I haven't seen anyone yet on this stream. Do we have enough people? Is the audio all right? All right, I think the audio is fine. I just checked it, guys. So I don't see a lot of people yet. But before we start, I just like to say, guys, sorry for delaying this stream here. I had some chores or some errands to run, and it took me some time to finish those errands. But anyway, we are here now. We don't have to worry about those errands anymore. So today we're gonna be doing question 3, because yesterday we already done the live stream on question 1 and question 2, and I've decided that we should take an hour to do the live stream. If we want to do more, we will again dedicate another hour for another live stream, guys, because of the mic that I have. The mic that I'm using is audible, but it's very limited. It's limited to an hour. So when I look back on the previous stream after the mic was dead, I realized that the audio was not nice, guys. So you needed to have some headphones there in order for you to hear what I'm saying on the stream. But with the mic that I'm using at the moment, it's very limited. So an hour is enough for us to have a stream where you can have a nice audio, guys. Right? But anyway, you can comment there, guys, on the live stream. If you are here and you are oh yes, I can see Lawrence, Rapalalani, and Nakumba, Mahlatse, and Doctor. They are here. All right, welcome, guys. Welcome back. Yes, you can always comment there if you are here, guys. Shall we start? Shall we start? Or shall we wait at least 3 minutes, 5 minutes for others to be part of the stream? And we have Charlie there, says yes. Tabane, si Buyane. All right, our people are here, guys. I think we should start. They will find us on the way, guys. All right, so we're gonna do question 3. It's gonna take us an hour, and then we're gonna pause, and then I'm gonna give you a choice that whether we continue and do trigonometry, another previous question paper, and do trigonometry there, or we stop on question 3. But for now, let's do question 3. All right, people. So let's continue, people. Let's continue. I see Magagula. I see Unique. I see Lalose. Yeah, everyone says yes. So let's just start. So I'm gonna zoom this so that you can see question 3. Right. So question 3, guys. Let me zoom it. Can you guys see it? Right. So question 3, it's actually limits and differential calculus, right? So we're gonna start with limits. So I'm gonna have to explain certain things about limits, especially if you're not part of the full-time classes, guys, or you were not present while I was doing limits. I think most people were not present because I introduced limits on Friday, and Friday, man, people are hardly coming to school, and that's why we actually introduce new chapters on Fridays. Those who are full-timer students, please come on Fridays, guys, because we introduce chapters during those times. So we're gonna do 3.1 there, guys, and its limits, and the marks is for them, right? So let me zoom down. I'm gonna rewrite it on the left here, I mean on the right. right? Let me just rewrite it on the right here, guys, right? So the question is like this. You are given the limit. Let me just write it. The limit, and then x actually approaches pi over 2, right? And then what we have there, we have sine 2x divided by cos x, close bracket, to the power of 1. Guys, this power of 1, it was just to trick you guys. It's more like you don't have anything there, guys, right? Even if you don't write the power of 1, it was just a trick, guys, right? Don't get tricked, please. This was just a trick. Now let's start with limits. Let's do some revision on limits. So when you do limits, guys, there is 3 types of steps that you must follow. One of the step is direct substitution. Now, direct substitution, it's when you substitute x on the formula. So the direct substitution for this one here is when you substitute x on the equation. Wherever there is x there, you substitute with pi over 2, right? But this one is tricky. Let's just pause this one for now. Let's just pause the actual question and then just make an example with one of the questions. Now, let's say you're given this one, limit, let's say x plus 2, and then we say x approaches maybe 2, right? Now, guys, when we do the first step, which is direct substitution, basically what you do here, you just do direct substitution. You substitute x where there is 2, you substitute 2 where there is x, so you're gonna say 2 plus 2. So your limit for this one is 4. So if the direct substitution gives you a limit which is a number, then you stop there. This is where you stop. But if it so happen, for example, let me give you another example based on something similar to this. Let's say this time our limit approaches now, let's say our limit approaches 2, but the equation, let's say it's negative, let's say x squared minus 9 divided by x minus let's say 3, right? Right. Let's change the x as well. Let's say the x now here approaches 3 instead of 2, right? Now remember, I said the first step is direct substitution, and direct substitution, it is when you substitute x directly to the equation. So you're gonna do it on the side. You can say wherever there is x, you substitute with 3 to the power of 2 minus 9 divided by 3 minus 3. As you can see there, with the direct substitution, this 3 to the power of 3, this 3 to the power of 2 is going to give us 9 minus 9, so this is going to give us 0. Divide by 3 minus 3, that is going to give us 0, right? So this here, it means that our first step, which is a direct substitution, we not gonna use it, because whenever you use direct substitution and you get 0 divided by 0 or infinity, sometimes the answer is infinity, just know that direct substitution, it is not it. So you have to move to the second step. Now the second step, it's simplification, right? It is simplification. Basically what you need to do here is you have to simplify this equation here, right? Now if I look at this equation, I can simplify it. The numerator there is a difference of 2 squares, guys, right? We have x minus 3 and x plus 3. This here is a difference of 2 squares on the numerator there, right? Divide by x minus 3, right? So this x minus 3 dividing this x minus 3 is going to give you 1 multiplied by x plus 3. So this part here, we are simplifying. So after simplifying, now that our equation is simplified, we go back to direct substitution to this first point, right? So we know that x approaches 0, so wherever there's x, we're gonna substitute with, we know that x approaches 3, guys, not 0. It approaches 3 here, so wherever there is x, we're gonna substitute with 3. So we're gonna say 3 plus 3, so your answer here is gonna be 6. So remember, you only use this second step, which is simplification, when the first step here, which is the direct substitution, gives you 0 or infinity. You guys understand? I hope you understand. So the second step is you simplify. After simplifying, then you go back to direct substitution. Then you get the limit there. Now, we have the third step, guys. Let me try to explain the third step before we finally do our question there, because I find it to be very important for you to understand this, guys, right? The third step usually, guys, the third step usually, you'll be given a question that x approaches infinity. Most of the time, when x approaches infinity like this, it means that you must use the third step, because sometimes the third step, they will give you something like this, maybe 3x plus maybe 2 divide by let's say um 2x minus 3. I'm just making an example, guys, right? So obviously, if you do direct substitution here, you will have infinity, guys, right? x up x approaches infinity. There is this information that you need to know. When you multiply a number with infinity and you add it with infinity, add it with another number, it's gonna give you infinity, guys, right? So if you multiply or divide, it's gonna give you infinity, right? But there is some information that you need to know, which is very, very important. When you divide any number, I'm going to use 1 for example, by infinity, the answer is going to be 0, right? So this information here is very important. You can multiply by infinity, you can add by infinity, the answer is going to be infinity. You can subtract any number by infinity, the answer is going to be infinity. You can divide infinity with any number, it's going to be infinity, guys, right? But when you divide any number by infinity, then the answer is going to be 0. So the aim is to have what we have there in the box, guys, right? I hope you guys understand. If you don't understand, do not forget to comment, guys. I'll try to be quick because our mic here, it will die very, very soon. So let me be quick. So the first step is direct substitution. It won't work. The second step is simplification. This is already simplified, so there is no any way of simplifying this. So the third step is dividing with an x that has the highest power. If you look at this equation here, the x that has the highest power is the x with the power of 1. Sometimes it's x to the power of 2. Sometimes it's the x to the power of 3. But as you can see here, the x's that we have here, the highest power on this axis is 1. So what you do here, you divide each and every term with an x that has the highest power. So the first term on the numerator, we have 3 x divided by x, because x has the highest power on this equation here. And then the second term on the numerator, we have 2 divided by x, right? And all this is divided by 2x divided by x minus 3 divided by x. All right, I hope you guys can understand here. Now let's continue. Now, when you finish dividing here, obviously the first term on the numerator, we have 3x divided by x. This x and that x, they will divide each other. You'll be left with 3, right? Plus 2 divided by x, right? On the numerator, the first term, on the denominator, the first term on the denominator, we have 2x divided by x, and then this x there and that x will divide each other. You're left with 2 minus 3 divided by x, right? So when it's like this, you are done. It's time for you to do the direct substitution, right? So on the first term on the numerator, we have 3. There's nothing you can do there. We don't have x. But on the second term on the numerator, we have 2 divided by x. But wherever there is x, we substitute with infinity, right? Divide by. And then on the denominator, the first term, we have 2 there. And then the second term, we have 3 divided by x. But instead of writing x, we divide by infinity. Right. Just create space here very quickly. Now, When you continue there, remember earlier on I did say any number divided by infinity, you will have 0 there, guys, right? So let's look at the first term on the numerator. We have 3 there, and then the second term we have 2 divided by infinity, so this is going to give us 0. Then we say divide, and then on the denominator, the first term we have 2, and then the second term we have 3 divided by infinity. This is going to give us 0. So the limit here is going to be 3 divided by 2. So guys, this one here, this method that I just showed you here, is the third method. Only when the x is approaching infinity, most of the time you do this one, guys, right? And don't forget that we divide by x with the highest power. In this case, when you look at our equation here, right, the x with the highest power, it was just x. That's why we divided by x throughout here. If this x was squared like this, we're going to divide by x squared throughout here, guys. Do you guys understand? I hope you understand. Right. So with that being said, now let's look at our main problem from this question here, guys. Right? Am I still audible? Please alert me, guys, as soon as possible. I don't trust this mic, guys. I need to buy a high quality mic, right? So let's hope this YouTube channel is gonna make money for us, so that I can buy a good equipment for you guys. Because I'm thinking for test 2 we should do the same thing, but I'm thinking the best thing that we should do here is to do question by question, because trying to stream the whole question, it's tiring, guys, right? And it takes too long, and we make a lot of mistakes. I make a lot of mistakes. But anyway, are we still okay, people? Are we still okay? You can comment there, guys, if you're still fine. Now, thank you, Velase, said loud and clear. All right, so I'll continue. Now let's look at our question here. So our limit here, we have x approaching pi over 2, and we have sine 2x divided by cos. Guys, what you should understand here, is that this here, the pi over 2, it is actually rads, right? It's radians. So what you need to understand here, you cannot do direct substitution with radians, guys. I always tell people, whenever you see pi, anything that associates with pi and trigonometric ratio, whether it's sine, it's cos, it's tan, or anything that has to do with trigonometric ratio, you have to change your rads into degrees, or change your calculator to display R there on top. But I wouldn't advise you to do this, because it's very risky. You might forget as you continue with your test. So the best way is to change the rads into degrees. So this pi over 2, it's actually in rads. So the best thing that you must do here is to change this. So if you were attending in class, I always tell people that when you change rads to degrees, right? Degrees, right? Is this how you write degrees, guys? I think this is how you write degrees, right? You multiply your rads with 180 divided by pi, right? So when you multiply this 180 divided by pi, when you multiply the rads here, the pi and the pi will divide each other, and then you say 180 divided by 2, meaning this in degrees now it becomes 90 degrees. So instead of substituting pi over 2, rather substitute the 90 degrees here. So I'm going to write in red here, guys, to remind you that we already changed this into degrees, right? So I'm going to write in red there to remind you. So before you tackle this question, you need to make sure that you check what our x is approaching them. If it's given in rads, please change it into degrees. Right. So let's do direct substitution. Remember, the first step, it's direct substitution. So let's do it. So you're going to write sine 2 multiplied by 90 degrees, right? Divide by cos 90 degrees. Guys, in your calculator, you cannot, some of you cannot do this, right? So I'm going to show you how to do this, guys. Oh yeah, you can do it. You can do it. This is simple in your calculator. Just put it as it is, guys, on your calculator. This one is simple, but there is others where it's I see people struggling to write that on a calculator, right? Or to input this information on the calculator, right? So guys, when you put this on a calculator, let me just put this on my calculator very quickly. Sine 2 multiplied by 90 divided by cos 90, right? So my calculator, it says error there. Basically, this means that this is infinity. So remember, I did mention earlier on, when you do direct substitution, if it gives you infinity, the next step is simplification. So it means now we need to simplify our equation there. So I'm going to erase this very quickly. We need to simplify this. It is, so if you look at this, guys, you need to know your trigonometric ratios, guys. So you must continue and try to simplify it. So x approaches pi over 2, but we know that pi over 2, it's actually 90 degrees, right? Right. So if you look at the numerator, we have sine 2x. Remember, guys, you need to know your identities. So sine 2x is actually double angle identity for sine. So it's the same as 2 sine x multiplied by cos x, right? But let's not forget that this this identity is divided by cos x there, right? Guys, you need to know your double angle identities, especially these ones here for cos and for sine, because they are not there on the formula sheet. Unfortunately, guys, you need to know them, right? So after simplifying this double angle identity, look, we have cos divided by cos. Now what is it that you left with? You left with 2 sine x. Do you guys see? This is after simplifying. Now after simplifying, what you need to do here, you must do the direct substitution. Now you have 2 sine, instead of writing x, now you're gonna write our 90 degrees. So what is 2 sine 90 degrees? So you put that on your calculator, 2 sine 90 degrees, you will get the answer of 2. So here, this one, guys, is our limit. So our limit here is 2. Guys, I hope you managed to understand this one, guys. Really, it was not tricky, but if you didn't know the steps that you need to follow, you're going to be confused. And especially whenever you see a pi here, guys, right? Whether it's pi over 2, pi over 3, or 2 pi, whatever, and you have a trigonometric ratio on this here, whether it's cos, sine, tan, sec, cosec, guys, please change this into degrees, guys, right? So how do you do it? You multiply your radians, right? I'm gonna do it again with 180 divided by pi. So this will take you to degrees, guys, right? Right. It will take you to degrees, which is gonna be 90 degrees. Some people, they just divide by 2 here. It's still fine, but I think it's better if you just use this formula. Whenever you move from rad to degrees, please multiply by 180 divided by pi. All right, I hope this was easy, and I hope you managed to understand. So let me show you how we're gonna mark this one, guys. First of all, we're gonna mark when you change this um, trigonometric ratio into this double angle identity. If you change it, we're gonna mark it. And also when you substitute there, we're gonna mark. And also when you change, or when you do the first substitution, guys, the direct substitution, and also when you get the answer. So this was out of 4 marks there. So this is how we basically, how you're gonna do it. So it will also depend though. If you have a lot of steps, maybe we can even mark other steps there, or decide to mark this really. But make sure that you have the correct steps. You change this and you substitute as well. Show us your substitution, guys, right? And then your answer as well. Right, sometimes this question is out of 3, sometimes it's out of 4, just like now. All right, people, Did we understand this question here? Did we understand 3.1? Before I erase it, did we understand? So I'm gonna pause for a minute or two. I'm gonna make myself some nice tea, guys. So let me pause, let me wait, and then let me see if you guys can respond. Please say yes if you understood, and please ask a question if you did not understand. Right, I'm back, guys. I'm not seeing anything here, no comment at all. I will assume that people understood then. I assume that people understood. I am going to erase this work here, guys. Right, I am erasing. I'm erasing. Lawrence understood. Doctor understood. Right. Uh, all right. So others, they will keep quiet. All right, if you are keeping quiet, I assume you understood, people. I assume you understood. Seku understood. Seku just said yes, so I assume Seku understood as well. Right, let's look at 3.2. All right, it seems like everyone understood, guys. All right, it's fine if you understood, guys. I think most people, they already shown that it was understandable. Right, let's look at 3.2 again. I'm gonna zoom 3.2. Charlie understood. All right, people. Yeah, we have Taban say, you said we only simplify if our answer is 0 or infinity. Yes, Taban, when our answer is 0 or infinity, when we do, don't forget that when we do a direct substitution and we get 0 or infinity, we simplify. And if simplification it is not possible, guys, uh, you go to the third step, whereby you have to now divide by x with the highest power. Did you understand, Taban? Can you please respond before I continue with this next question? Sibuyane said I should wait. There is a question. What is the question, Sibuyane, before we continue with 3.2? So I'm gonna wait again, people. Remember, our mic, it's not giving us enough time, guys. We are working with limited time because of the mic that we have here. But don't worry, people. I'm gonna buy a very reliable mic. I am still accumulating money, right? Don't worry, I'll buy nice mic. We'll talk the whole day. I'll teach you the whole day, guys, and I'll be audible. Guys, I'm still waiting for Tabane, and well, the other question is gone, but I'm still waiting for Taban. Tabane, did you understand what I just said? To answer your question, I said yes. When you do direct substitution, all right, Taban is fine. Thank you, Taban. Sibuyi, your question. Sibuyan, what is your question, by the way? I just answered. Okay, all right, Sibuye. If I answered your question, then we are fine. Guys, ask questions, guys. All right, ask questions before we start with another question. I assume everything is fine, so I'm gonna continue, guys. All right, let's continue. We have 3.2 here. They want us to differentiate from first principle if we are given f of x as 3x to the power of 5 minus 6. All right, this one, guys, is gonna be long, so I need you guys to bear with me. I will try to explain certain things here. The reason why I'm explaining some of the things, guys, is because we have part-time students, and these guys, they don't attend full-time, so most of the things here, they might come as new to them, right? And we have people who not been to school for some time. Those part-time students, we have people who not been to school for some time, so I have to remind them, guys, right? So those who are in class, please bear with me, because I know you know these things that I'm explaining here. So when we derive from the first principle, before we even tackle this question here, guys, when you derive from the first principle, you must use this formula here. We have the formula where f of x prime is equaling to f of x plus h, right, minus f of x. And then we have to divide by h, and then we say limit, right, h approaches 0. I think everyone knows this formula, because if you have done if you have metric, you must remember this, guys, right? There's no way that you've passed your metric without knowing this. But if you did pass without knowing this, you have some explaining to do, right? So before we start with this, guys, you know that we have to substitute our f of x plus h and f of x. Now, f of x is given to us, guys. F of x is our question. Let me write it here so that you can see it. Our f of x, which is 3 x to the power of 5 minus 2. So this f of x here, let me highlight very quickly. This f of x here, which is part of the question, it's the one that we're going to substitute there on our formula. But our f of x plus h is something different. So let me just, we need to find f of x plus h. So let's find f of x plus h, right? So f of x plus h, right, it's gonna be the following. It's gonna be 3. So remember, f of x plus h, wherever there is x, we substitute with x plus h, right? So let's do it. So we're gonna have x plus h, but look at our x here. It has the power of 5. So we're gonna put the power of 5 there, minus 2. Do you guys see? Right. So most people, they are used to having squared here. When you have the power of 5, guys, it means that you have to have about 5 brackets like this, right? And start multiplying to remove the bracket, which is going to take you the whole day, right? So the best thing here is to use binomial theorem, right? So this is where most people, they get lost, guys. So let me try to explain binomial theorem here on this space, guys, right? So binomial theorem, you have something like this. When you have a binomial theorem, you have x plus h to the power of n, guys. So when you use the binomial theorem, you must able to expand this, because when you use binomial theorem, basically we are factorizing equations similar to this one here, where we have the exponent which is way too big for us to factorize in a normal way, right? So you must expand it to at least 5 terms, no, at least 4 terms. In your level, guys, it's 4 terms, right? So let me pause a bit. Jesus. All right, people, are we still together? Are we still together? Yes, will be very appreciated, my people. Please say yes if you're still clear, if you're not lost, because what I'm about to show you guys is gonna be a lot. All right, if you're not lost, please say yes. I'll really appreciate that. All right, so where are we? Yes, we're about to talk about, or about to show you the binomial theorem, guys. All right, so like I said, you'll be given something like this, guys. All right, now when you look at this here, right, you will have to expand to 3 to 4. You have to expand to 4 terms, right? You will have to expand to 4 terms, guys, right? So the first term is very simple. You're gonna have x to the power of n there. That is the first term, right? The second term, you derive the first term and you multiply by h. So meaning, when you derive the first term, you're gonna have n multiplied by x, right, to the power of n minus 1. Do you guys see? Multiply by h. This is the second term, right? Then the third term, you derive x, and then you will have h to the power of 2. So you derive this x here. This x here, you derive it. Now, when you derive it, you're going to have n, right? You already have n there. And then you multiply by that n there, guys. n minus 1, right? So you have to multiply by n minus 1. Then you divide by 2 factorial, right? 2 factorial. Then you multiply by x n to the power of negative 2 multiplied by h squared. Do you guys see? So if you look at the first term here, we had only x to the power of n. The second term, we derive this n here, we multiply by that n, and then we minus that n with 1. Do you guys see? And the third term, we are writing this n here, there, and then we drop this n minus 1 there, and then this time around, x to the power of n minus 2. I hope you guys can see. Really, I'm trying to explain this to my level best. And then this time around, we divided by 2 factorial. And let's not forget that our h here is going to be squared for this one. And there, our h has the power of 1. But even if you don't write it, it is still fine. Right. Now, our last term, which is the fourth term. Guys, don't go beyond the fourth term. Your level, which is level 4, which is n4, you only stop on the fourth term. All right, on this term here, you do the same thing. You multiply by n, multiply by n minus 1, multiply by n minus 2. This n minus 2 is this one here this time around. Do you guys see? And then you divide by the third factorial. Right, let's divide by third factorial, right? And then you have x to the power of n minus 3. Multiply by h to the power of 3, right? You stop on this term. Let me show you how many terms we have. We have the first term here, right? And then we have the second term there, we have the third term, and we have the fourth term. Don't go beyond the fourth term, guys. Don't go beyond the fourth term. The reason why I'm emphasizing on this equation of the binomial theorem, it is because it is not there on your formula sheet. So you need to know it. So the best way of knowing it is to know that we are driving x on each and every term here, guys, right? We are driving x there. And then as for h, we are actually adding h. The first term does not have h. In fact, it has h to the power of 0, but anything to the power of 0 is 1. That's why we don't write it there. And then the second term, it has h to the power of 1, so that's why we write it there. The third term has the h to the power of 2, and the fourth term has the h to the power of 3. As for factorial, the first term, which is this one here, it has the factorial of 0, which is 1, by the way, right? And then the second term is the factorial of 1, which is also 1. That's why we don't write these two term factorials, right? But the third term, it has the factorial of 2, and then the fourth term is dividing with the factorial of 3. Now, I don't know whether you know, guys, how to insert the factorial on a calculator. Guys, if you don't know how to insert the factorial on a calculator, please say something on the comment section so that I can able to explain this. But if you can, then don't say anything so that we can continue. So the reason why I'm showing you this formula of binomial theorem is because we have to use it here, guys, because we have this here. We have the power of 5. So you cannot do this without using the formula of the binomial theorem, right? Are we able to get this here, the factorial, this thing here, on our calculator? Right. If you don't say anything, I assume that we all can. So I'm gonna erase this formula. We're gonna write it again, guys. Let me just erase it very, very quickly. Right. Now, remember, this here, this equation here, we are trying to find f of x plus h. We already have f of x, guys. So f of x is going to substitute here. This f of x plus h, you're going to substitute it there. So let's get f of x plus h. All right, we have Tabane and Magagola. They are saying, please show us. All right, no problem, guys. I'm going to show you how to find this thing on your calculator. Now, I hope you have your calculators with you. Now, when you look at your calculator, you have to press the button shift there on your calculator. Then there is a button under the mode setup button that shows x to the power of negative. So here's what you do: you press shift first, right? Then you press this button here that has x to the power of negative 1. On top there, this button, it has x factorial there, right? Can you able to do it, Magagula and Tabane? Can you able to see the factorial on your calculator? You press shift, then you press this button here, x to the power of negative 1, which has x factorial on top there. You must able to see the factorial there, right? Can you see it? Yes or no? Matabane, I mean Tabane and Magagula. Please respond before we continue. Please respond before we continue, guys. Yes or no, Tabane and Magagula? Can you able to do that? They are not saying anything, guys. They're not saying anything. I assume they are fine. Oh, thank you. All right, Magagula said yes. All right. I assume that. Oh, yes, yes. So we are all fine, guys. We can know how to press the factorial. All right. I'll try to be quick this time around, guys. Okay. I'll try to be quick. Let's be quick. Let me erase this very quickly. Right. Let's erase it. Now, what we should do here, guys, is now we're gonna write 3 inside there, the bracket. Let's expand this to the third term, guys. When you are calculating for f of x plus h, you don't have to expand to the fourth term, just expand to the third term. So let's write the formula. It's better to write the formula. First term, we have x to the power of n plus n x to the power of n minus 1 multiplied by h. That is the second term. And the third term, I think the third term is fine. We're going to have n, and then we have open bracket, n minus 1 divided by 2 factorial, and then we have x to the power of n minus 2 multiplied by h to the power of 2. Then we close bracket. Let us not forget, let me just create a space a bit here, because people tend to forget the following. And then we say minus 2. Remember, we are looking for f of x plus h. Remember, f of x plus h is derived from f of x, guys, right? So most people here tend to forget this 2 here. They tend to forget 3 and negative 2. Remember, we have 3 and negative 2 there, guys, right? So here's what I'm going to help you to able to track this. You see all this here, right? This thing here, it is now expanded into these 3 terms, guys. To make your life easier, just extend this or expand this to 3 terms, guys. Whenever you are solving from the first principle, extend this to the third terms, guys. Don't go beyond that. You'll be wasting time. If you do, it's still fine, but you're wasting time. All right. So let's continue. Let's continue. So now when you continue here, now it's time for us to just substitute there, guys, right? Let me just write it here. We have this 3 there. So inside, we know that our n, remember this n here is what? Is 5, guys, right? So we're gonna have x to the power of 5. Oh, x to the power of 5 based on our formula there, or our binomial theorem, plus n multiplied by x to the power of n minus 1. So it's going to be 5 multiplied by x 5 minus 1 multiplied by h. Remember, our h is this one here. So this is going to be h. You guys still follow? Right. Now, let's go to the third term. So the third term, we have n multiplied by n minus 1. So remember, n is 5 multiplied by 5 minus 1 divided by 2 factorial, right? And then we have x to the power of 5, which is this n here, minus 2 multiplied by h squared. And in all this, minus 2. So again, I'm going to highlight this, guys, so that you can see that we are still inside the bracket there. All right, as long as you guys can see, we are fine. Let me just create spaces here, guys, so that we don't get confused. Right. So let's continue, guys. I'll try to be as quick as possible, guys. Our mic is killing us. Right, so from here we still have that 3 there. Now we know that x to the power of 5 is just going to give us x to the power of 5. But let's look at the second term there inside. We have x multiplied by, we have 5 multiplied by x to the power of 5 minus 1 here. So we're going to have 5x to the power of 4. But let's not forget we have h here multiplied by h. Right, so that's the second term. Now the third term, I need you guys to pay attention. I want you guys to do this. Can you take your calculator and put all this inside your calculator? You see what I put inside the box there? Put it inside the calculator. Make sure you do it, guys, because if you don't, you will make mistakes while you are practicing. I'm also going to do it, and then let's see if you're going to get the same answer. So you take all that, you put it in the calculator. We have 5 open bracket 5 minus 1 divide by 2. Oh, yeah, divide by what is it, 2 factorial, guys, right? 2 factorial. I already showed people how to press 2 factorial. What do you get? I am getting, guys, 10 here. I hope you also get 10 as well. And then we look at this x here. We have x to the power of 5 minus 2. This is going to be x to the power of 3. Let's not forget we have h here multiplied by h. So all this outside the bracket, we have minus 2. Again, I am going to highlight this inside there. Right, my people. Are we getting 10 there? Thank you. Mashlas, what is it? Mashlat. Yes, Futi Mashlat. Thank you, guys. Yes, Bali also got 10. Yes, guys. Right. Please make sure you also do the calculations as well, people, because if you don't do the calculations, you will be lost there. Right. Now, look at this. Now we have to remove the bracket. So this 3 here is going to multiply everything that is inside the bracket. You guys see? Right, so let's multiply everything that is inside the bracket with the 3. If we say 3 multiplied by x to the power of 5, you're going to have 3x to the power of 5. And if we say this 3 multiplied by 5, x to the power of 4 multiplied by h, this is going to give us plus 15 x to the power of 4 multiplied by h. And then the last one, we say this 3 here multiplied by 10 x to the power of 3 h. This is going to give us 30 x cubed h, then minus 2. So as you can see now, guys, we have removed the bracket. Guys, do not forget all this thing here, it's x, it's f of x plus h, f of x plus h. We are not even started to do our first principle. We're just calculating f of x plus h. So all this here, guys, let me highlight with the blue color. All this here, guys, is a f of x plus h, meaning we need to substitute this f of x plus h on our formula. Let me show you where. We have to substitute it there, guys. We have to substitute it here, right? So we do have f of x. We're gonna substitute it there, and then our f of x plus h, which is this one here, we have to substitute it there on our formula. So I am going to create a little bit of space here so that we can able to do this. Our mic is still fine, guys. I managed to charge it longer enough. Hopefully it won't stop at the end of our calculations. Right, let's continue. So let's start substituting from our formula, guys. Right, so I'm gonna create the space here and draw the line. So f of x prime, right, wherever there is f of x plus h, this one here, we're gonna substitute with this long thing here, guys. Right, so f of x plus h is 3 x to the power of 5 plus 15. Oh, what did I write there? Plus 15 x to the power of 4h plus 3, plus 30 x to the power of 3h, right, minus 2. All these guys is actually f of x plus h. Now let's not forget, in our formula there, we are minusing with f of x there. So we must say minus, but always put f of x inside our bracket. So f of x is actually 3x to the power of 5 minus 2, close bracket. And then all this is divided by h. There we go, guys. Let's not forget limit h approaches 0. Unfortunately, you have to write all these things here. Guys, can you see on your phone there? Because now the writing is getting smaller and smaller and smaller. Oh, someone said, what happened to h squared? Oh, yes, I forgot it. Thank you. Thank you. Thank you. Who is this? Oh, what happened to h squared? I forgot it, guys. Thank you. Who is this? You guys are very vigilant. Thank you, Sibuyane. Yes, Sibuyane. Thank you. Thank you for Sibuyane and Tato. I think they managed to see a h squared there. Yes, and Devane. Yes, yes. Oh, we forgot it, guys. Right? Yeah, I forgot it. Remember, I'm trying to be as quick as possible, so I'll make a lot of mistakes, guys. If you see some mistakes, please, 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 please alert me before we go further. Right? I will still find people. I fix the h squared. Is everything fine? Who said Glaloso? Say it is fine if it sends a using the easiest way. I don't know the other way, Glaloso, that you're talking about. If it's easier for you and if it's mathematically correct, then it's fine, right? So let's continue, guys. F of x prime, and then we know that limit h approaches 0. There we go. Now, unfortunately, you have to rewrite everything there, guys. We have 3x to the power of 5 plus 15x to the power of 4h plus 3, oh, 30, I mean, x to the power of 3h squared. Unfortunately, this one, you cannot do anything here because this is f of x plus h. But if you look at f of x plus h, we have a negative sign here. Do you guys see that negative sign? That negative sign is going to multiply everything that is inside the bracket there. So when that negative sign multiply everything inside the bracket, the signs they're going to change for all this. So we're going to have negative 3x to the power of squared, oh, 5, I mean, not squared, and then we're going to have positive 2 there. And all this is divided by h there. Can you guys still see? Because the writing is very, very small. Let me try to zoom in because now we are able to do this in a right in a what is this in a full screen now. Right, so I'm gonna put it on the screen. I hope you can see, guys. Now on this stage here, guys, this is where you come across the like terms. Now what you should pay attention, the like terms, guys, here, they should not have h. For example, if you look at the first term here, we have 3x to the power of 5. It does not have h. It must have its counterpart. It must have its negative part. So any term that has h does not have a like term. So the second term has h, as you can see there. The third term has h, as you can see there. So we skip it. And then as for the what is this? How many term? The fourth term, we have negative 2. It does not have h. It must have its counterpart. It must have the like terms, guys. This one here. So let's look at the first term. We have 3 to x to the power of 5. You must have negative 3x to the power of 5. Here is our negative 3x to the power of 5. So they're gonna cancel each other, this one. And then we have negative 2, this one here. It must have positive 2 there, guys. All right, so I hope you can able to understand at this step here, guys. Make sure that you only have the like terms of terms that does not have h, guys, right? If it so happen that you have terms that are uh, that are having h and they are subtracting each other, you made a mistake somewhere there, guys, right? You forgot to put this bracket, right? Let me continue, guys, because hey, time. Now let's continue. So what is it that you left with there on the numerator? So you're gonna be left with 15 x to the power of 4h plus 30 x to the power of 3h squared. All this now is divided by h. Limit h approaches 0. All right. Am I still audible, guys? Am I still audible? Are we still understanding each other? Right? Please comment if I'm no longer audible, guys. Right? Now, this is what you are left with. Now, this step on its own is very important, guys, because this step here, the only terms that you should be left with, they must have h. As you can see, these two terms that we are left with, they have h. If you are having any other term on the numerator that does not have h, again, it means you've made a mistake somewhere. You forgot to put the bracket. That is the actually common mistake here. You forgot to put the bracket here, and that's the reason why you don't have h there. Right? That's why you have the terms that don't have h there. Right? So let's continue, guys. Let's continue. This is very long, but it is how you're supposed to do it, people. Now let's continue. We have f of x prime, and then now we're gonna on the numerator take out h, because if you can see, these two terms, they have h as a common factor. So we take out h, and then the first term we're gonna have 15x to the power of 4, because we have only h to the power of 1. And the second term we have 30x to the power of 3, and they're only left with h there. Divide by h, right? And then we say limit h approaches 0, and then this h and that h, they will divide each other. And then I'm gonna continue here, guys. Let me continue on the other side. We will have f of x prime, and then limit h approaches 0. What is it that we left with after dividing here? We're gonna be left with 15x to the power of 4 plus 30x to the power of 3h. Are we still together, people? Are we still together? Okay, you can see. I'm glad you can see Cleopatra. All right. Remember, h approaches 0 there. Now, after dividing with h then, now the only thing that we need to do here is to just substitute our h there with 0. Remember, our h approaches 0. So on this step here, you drop this information here. Let me just highlight it. On this step, this information here, drop it, because now you are substituting, guys. Right? On this following step, that information, you drop it. So wherever there is h, you substitute with 0. So you have 15x to the power of 4 plus 30, and then we have x to the power of 3. Wherever there is h, we put 0. Remember, h is approaching 0 here, guys, right? So the final answer is going to be f of x prime is equaling to 15x to the power of 4. Anything multiplied by 0, this is going to be 0. Even if you don't write it, people, this is your final answer. I hope you managed to understood this. Yes, it looks long. It is actually long, but if you practice this, guys, okay, if you practice this type of questions, you will see that it's really not that long, right? What I'm worried about is the binomial theorem part, because people tend to try to avoid it. Like Mdlalose, they said, Melis, is it fine if they use the easiest way? Guys, I don't know the other way. I know that there is a other way where you can use some sort of a triangle. I never really spend time to learn that one, but if it mathematically it makes sense, guys, it's fine, people. It's fine. Just use it. Just make sure that you use it and you understand it. Don't use something that you don't understand, people, because you will be confused. Did we understand? Do we have any questions, guys? Any questions concerning how to do this question here? As you can see, that question, it's 6 marks. Sometimes it's 5 marks, guys, right? So it depends. Please make sure that you know how to do this one here, guys, right? So I'm trying to zoom down to show you mark allocation before you before you we erase this. Mr. Nkuna, what is it that you said? We don't we also divide by 15 before we replace with 0? No, Mr. Nkuna, we don't divide by 15. 15, No, we don't divide by 15, Mr. Nkuna. No, when you get to this point here, Mr. Nkuna, you just substitute h with 0. Basically, those are the steps that you must follow. Guys, remember our f of x, let me just write it here. It was 3x to the power of 5 minus 3. You can use the shorter method. Remember, the shorter method is as follow. When you derive, you multiply by 5 this x here, and then you multiply this 3, and then the x5 you minus by 1, right? And then this is a constant, so it's going to give you 0. So 5 multiplied by 3 is going to give you 15, and then the power, we have 5 minus 1 is going to give you 4. So as you can see, this here is the same as that one. This is a shorter method. So please, if they say derive from using from derive from the first principle, basically they know that you can do this in a shorter method. They want you to do all the things that we just did here, guys. If they say first principle, please do not use the shorter method here. You won't get all the marks, guys. Please don't use the shorter method, but you can use the shorter method to check your final answer whether it's correct, right? And I know people sometimes they write whatever they write here, and then they write the correct answer at the end. I will see, guys, I will see whenever we mark, we check the steps here, guys, right? So let me show you how we mark this. First of all, we're gonna mark you when you simplify this. So we're gonna mark the simplification there. We're gonna mark the substitution of f of x and f of x plus h, and then we're gonna mark these steps here where you separate, when you cancel the like terms, and we're gonna mark this part here. How many marks now? All right, then we're gonna mark the substitution and the final answer. Then sometimes if it's out of 5, usually we don't mark these steps here. This one here, we don't mark it when it's out of 5, but the substitution and the final answer, guys, always. And the substitution of f of x and this part here, that part and this part, make sure you include them, guys, right? Make sure you include them because they are always there. Those ones are always there. And this one here or that one, right? If it's out of 5, right? I hope you guys managed to understand this. It was not really that difficult, people. Anyone who has a question, please let me know. We are done with question 3 here. So I am going to, in fact, now that we are done, I think I am going to end this stream here. Now I have a question for you guys. If you someone before I asked that question, let me read Mpo. And Mpo is asking this question, yeah. Is the logarithmic and exponential differentiation going to be in the test? No, it is not going to be in the test 1. I did mention to a lot of people that we stop here. We stop on first principle. Mpo, that is a good question, by the way. Don't look at those ones, guys. Usually we include them on test 1, but we realized that time was not on our side, so we decided to cut uh, our differentiation on first principle and binomial theorem. So don't go further than here, guys, right? Stop at binomial theorem, first principle. That's basically where we're supposed to stop. The reason again is that test 2 is now set regionally, so they also set trigonometry. No, they don't set trigonometry, they actually set calculus. So rather we do half of it and then we do the rest of it when we're done with test 1, right? All right, so Mpo, that was a good question, by the way. Anyone who has a question concerning what we did here, if you guys understood this, and then that's good, people. Our mic didn't fail us today. I'm very happy. So here's a question that I have for you guys. We can create another stream for another hour for trigonometry. Are you guys okay with that? Let's take 30 minutes break. Let me find another question paper where we can also do trigonometry to revise again. Are you fine with that, or this should be the end of our stream for revision? So I will hear from you guys. Is if you are willing to do another stream that will start at least 10:30 or 11:45, and then we're just gonna do trigonometry on that one. I'm gonna look for another question paper for test one, and then we do the revision on trig. So your yeses and nos will be highly appreciated. So comment there, guys, or we should just stop this. All right, this is should be the end of our stream. So what are you guys thinking? Another stream, say. All right, doctor said another stream. So let's hear from you guys. Vote, please vote, just like last time about this. Let's vote and let's hear what other people are saying. Another stream, please do it. Okay, Musa said please do it. Right, guys, make sure you comment, people. Right, yes please. Okay, yes please. All right, people are saying we should. Right, comment, people, comment, so that we can charge this mic of ours. The mic is failing us, guys. It usually takes an hour. I'm so surprised that it's still on, you know. So and my energy, guys, it's high, very high. Yeah, I managed to rest today, guys. I managed to rest, and I also managed to do the things that I was supposed to do before I start the streaming. I ate, I drank my coffee, and yeah, I took some. I did some few push-ups. I'm feeling hyper. Okay, asupinde. All right, zizopinda senzo. Another one. All right, people. So people are saying we should do another stream, right? So let's end this one. Let us not waste any time, guys. I assume question 3.2, everyone is fine with it. I'm glad that everyone managed to understand it, guys. So I'm gonna end this stream here. I'm gonna set another stream. I'm gonna send the link on the YouTube, on the channel, on our WhatsApp. Please, guys, if there is someone who's not part of the WhatsApp group, share the link with them, because I assume that everyone who's here is part of the WhatsApp channel. Share with them, guys. Anyone who's doing N4, whether it's from our college or any other college, share with them, guys, because some people probably, they don't understand these things, so this stream might help them. Right, people. I'm ending this stream. Thank you very much for watching. So we're gonna do another stream. We're gonna focus on trigonometry, because yesterday I realized that our trigonometry was not on par. Our audio was bad. I was also tired. Fatigue was killing me, guys. Right, people. See you on the next stream. We're gonna start the next stream around quarter half past. Let me just do 25 to 11. Hopefully it's gonna take us less than an hour, just like this one. Right, guys. I'm ending this stream here. See you guys on the other stream.